Homework 4.2, Logarithmic Functions, Video 6. Homework due Friday, May 29th at 11:59 p.m. The following video is directly associated with questions 23 through 24, but is also incorporated in 19 through 22 as part of those questions. Domain of a logarithmic function. Shouldn't surprise you that we're talking about a new function, so we're going to discuss its domain. When we talked about domain issues previously, we had seen three types of domain issues. For a polynomial function, the domain was all real numbers. For a rational function, a function that has a fraction and an x in a denominator, it was all real numbers except solutions to denominator equals 0, because we couldn't let the bottom of a fraction be 0. If you want to review these, go back to homework 2.6, where we talked about combinations of functions, or the videos for homework 6, I should say. Homework 2.6. And we also talked about radical functions, specifically square root functions, but we had to solve radicand greater than or equal to 0, and the purpose of that was to prevent any imaginary or complex numbers, rather I should say non-real numbers, showing up as outputs, because our functions were only real valued functions. This avoided square roots of negatives. And I also hinted that there would be a fourth type of domain issue in the future, and here it is. The fourth type of domain issue is logarithmic function. Now, I'm not going to write how to do it here. That's what this space is for. So what's the domain of a logarithmic function? Well, in order to do that, let's remember what the graph of this looked like. Now, I know we just drew a real quick graph earlier, and we didn't talk about the case when the base was less than 1, because the one we did was log base 2 of x. But if the base is greater than 1, then our function's graph looks like this. And we had actually listed what the domain was. Go watch the first video. It was 0 to infinity. The range was all real numbers, but we're only talking domain here. One thing we didn't do was talk about what happened if the base is less than 1, but still positive. Well, if we did the same thing we did before, but with 1/2 to the x, we would have gotten the mirror image of this across the x-axis, so it would start high along the asymptote and go low. But the domain is still the same. So what does this mean about the domain of this function? Regardless of whether the base is bigger than 1 or less than 1, we can only put in positive numbers. We can't put in 0. We can't put in negatives. And if you think about it, it makes sense. Because what's the answer to a log? A power that turns the base into the argument. So this will be a power that we put on something. And since this is positive, it will either be positive or the reciprocal of a positive, which is still positive. So the argument must always be positive. So, what we know about the domain of a logarithmic function is that the argument must be positive. We must have argument greater than 0. Now, this particular function's argument is just x, so its domain is 0 to infinity, like we already saw. But let's say we have something where the argument is more than just x. For example, let's say we have g of x, just to change things up, equals log base 1/2 of x minus 7. And the question is, what's the domain? You can only log positive numbers because you must have the argument greater than 0. The argument of this logarithm is x minus 7. So all you have to do is solve x minus 7 is greater than 0, not greater than or equal to, just greater than. Well, this is easy to solve. X is greater than 7. My 7s and my greater thans are starting to look alike. X is greater than 7. On a number line, that's everything to the right of 7, but not including 7, so parentheses, and therefore the domain in interval form is parentheses 7, comma, infinity, close parentheses. So solving the domain of a logarithm is simply solving an inequality. Now, there are various inequalities, and the way that you solve them depends upon the way the argument is set up. So for example, if we had h of x equals natural log of x squared, let's say x squared, think about this, minus x minus 12. To find the domain, we still set it up the same way. We solve the argument greater than 0, so we got to solve x squared minus x minus 12 is greater than 0. But solving this quadratic inequality takes more work than solving this. Just a reminder on how to solve any inequality. It would even work for these. You pretend it says equals. So x squared minus x minus 12 is equal to 0. Solve it by your method of choice. I choose factoring. You may choose the quadratic formula. This factors into x minus 4 and x plus 3. Think about it. We get solutions of x equals 4 and x equals negative 3, but it's not the end. When solving a polynomial inequality, these numbers partition the number line. So you get out a number line and you cut it at negative 3 and 4. Then you pick test values out of each interval. So a number to the left of negative 3 might be x equals negative 4. A number between negative 3 and 4, I choose 0. I'll choose 0 when I can. And a number greater than 4 like 5. And then you test in the original inequality. And honestly, we could test in the original inequality or its factored version, but for consistency, I'll just stick with the original. So I'm going to test negative 4 up here. Negative 4 squared minus negative 4 minus 12. Is that greater than 0? Negative 4 squared is 16. Minus 4 is plus 4. Minus 12 is greater than 0. Yes, it is. I don't need to go any further. 20 minus 12 is 8. That's true. Yes. So we want that interval. Do we want the interval with 0? This one's easier to check because if I put 0 everywhere there's an x, 0 squared minus 0 minus 12 is greater than 0. But the zeros disappear on the left and we have negative 12 is greater than 0. That's a big no. No, it's not. We don't want the middle interval. And if we test the 5, 5 squared minus 5 minus 12, is that greater than 0? Well, let's just do it real quick. 5 squared is 25. 25 minus 5 is 20. 20 minus 12 is 8. Yes, that's a keeper. So we want the interval on the left and the interval on the right. We use parentheses and not brackets because it doesn't say or equal to. So our domain would be from negative infinity to negative 3 parentheses, doesn't say equal to, union 4 to infinity. So your domain questions can be either really easy and quick or not as easy or quick. They all depend upon the type of argument. Now, to be fair, I should disclose which of these questions involve trickier inequalities like the last one, so I'm just curious. No, 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 really? I only gave you ones that were this caliber? How disappointing. Well, how disappointing for me. I bet you're wiping your brow saying, oh good, I don't have to do that second one. But it is nice to remember how to do the things from days gone by.